David with EV World News. We're talking about electric vehicles, green energy, and the stock markets. And I'm back today with a resident engineer, Mike Herzog, and a special guest, Jeremy McCool with HEVO. How are you doing, Jeremy?
Hey, that was the best intro I've ever seen for any EV podcast or webinar, anything I've ever done. I might need to take a little bit out of your playbook and reuse that if that's okay.
No, it's fine. And you're welcome to reuse anything. I mean, I'll give you access to all the files. You're welcome to, you got free use of anything that we do on the show. And we will later on, we'll have some, my editor will come in and he'll pull some stuff from the show, and you're welcome to, reuse that too as content, for LinkedIn or whatever. So it's, I think we do this right with guests, and we try to make it so people can get more and more out of the experience. Anyways, Jeremy, I've actually talked a little bit about you on the show previously because you're looking at a different aspect. We talk about electric vehicle charging all the time, and and you and I have previously had about a 45-minute call talking about all the different things going on charging, what we think is going to win in the long term. And when people really look at electric vehicles and what's going on, everybody just assumes they're taking an extension cord basically and sticking it in the car like they're powering up their chainsaw and powering it up that way. And to a certain degree, that's what most chargers are. But you're in the wireless charging space, which, I love wireless charging for my phones. Do you want to talk a little bit about what you're doing at HEVO, and let's start where how this all came about? You're in the wireless charging space.
Yeah, so it's funny that you bring this up because it is kind of like the wireless charging for your phone, but just much more efficient and much more powerful. So we're able to achieve up to 93% efficiency from grid to battery, which is remarkable, and that's taken some time. Like, we didn't start off that way. We were in the high 80s, lower 90s, and there were some really remarkable things that happened with parts and suppliers that were working on things related to, say, like solar and distributed grid and also data farms, that as they were improving those inverters, they were also giving us the capability to improve our supply chains and our parts that we could select for, that made it just more efficient and made it also more powerful. So we had the coupling capability to utilize things that were off the shelf to improve our overall architectural mix, if you will. But at the end of the day, this is wireless charging for vehicles. And what we're trying to achieve is basically it's this. We know that people can plug in their cars and do that pretty easily, right? Like, let's not act like that's not an easy thing to do for most people who are going, say, to their home garage. But there's a lot of forgiving that has to happen when you go into a public location or a fleet location. Certainly, there's going to be some key challenges that people who have not operated with plug-in charging of any sort of like this in their lives, they're going to go through this level of disenchantment with the entire process. I've been an EV user and driver now for over a decade, and I've seen it all. I've had to experience it all. I've heard it all. And so what we can say is this. Yes, it is more convenient upfront. That's the easy answer. But the other things that it can do that is just really remarkable is that we do bidirectionality. So all of a sudden your vehicle becomes part of the grid equation. If your vehicle is sitting inside your garage or outside in front of your home or in a garage at a condo, one thing that you could automatically see happening is that these are really just big battery packs with wheels on them. And they're going to locations that may need to have power at different points of the day when the grid is idling or there's some other challenges going on with the grid. And so redundancy still is something that needs to be resolved in the United States, especially, and we'll just say in any kind of location that is experiencing this level of extreme AI on-ramping along with EV on-ramping at the same time. These are highly energy dense types of technology industries, and they're converging at the same time. So if that's going to happen, we're going to need redundancy. And one of those opportunities that we present with our wireless charging solutions is to be able to do that with the bidirectionality portion of your vehicle's battery pack, being able to offset some of the power required for your home. So your home could technically be powered by the car. To bring it back though, and kind of spin this back into the question about how and why, It's really about trying to solve the common charging anxiety problem that everybody is experiencing with electric vehicles. So charging anxiety is what we have been seeing as the most reported problem, not range anxiety, meaning people just don't know how to charge or where to charge or what that process will be because it's not standardized and it's not a simple thing to just step into. So that's what got us to where we are to start the company. And we're celebrating 14 years on Saturday, which is really great.
Wow.
We were really ahead of the curve, and we had to be because the technology took almost a decade to develop to a point where we could say it was a certified and we would say also an automotive approved system. So now it's been the last 3 to 5 years of our lives has been spent around working with major automakers to develop programming for wireless charging with their upcoming production series vehicles.
Now, I think you told me that the first vehicle you've seen it sort of standardized on is the robo-taxi from Tesla, right?
Well, the first company that we ever saw wireless charging come out with was the BMW 530e. So that actually had wireless charging on it several years ago. It didn't really launch, unfortunately. The vehicle and some other things happened there, but we'll just say the vehicle didn't really sell as they had hoped it would. And so therefore the wireless charging wasn't really selling because it was packaged with. The other side of that answer is that Audi did release the e-tron with wireless charging hookups on it in preparation for the idea that wireless charging would be on cars at some point. And still, yet they weren't able to find a supplier to meet those requirements back then. So now, fast forward, Porsche has officially announced that they will have wireless charging and have already started to showcase it and demonstrate it at different roadshow events. And they've been doing that now for the last couple of months. But they made that announcement a few months ago with the Cayenne. But we did hear about 12 to 18 months ago that Tesla with the Cybertruck already had wireless charging on it. It was discovered by Monroe, who is Sandy Monroe by the namesake. It was discovered by Monroe and Associates when they were doing a tear down of a Cybertruck. They found the hookups, which were really strange. They didn't know what it was. And they went to the owner's manual and it said that it had induction in the owner's manual, but it wasn't released. Now, what we do know is that the Cybertruck team has officially announced that they're not going to put wireless charging as an option, or at least release wireless charging as an option to their customers. So that opens the door to an interesting possibility for aftermarket for these 50,000 plus Cybertrucks that have been delivered to date that could have wireless charging. And then the final point of this, of what you stated, David, is what about the robo-taxis? And certainly around this time last year, when the robot series, that event that Elon and the team at Tesla were doing, when they made the announcement of their Cybercab and they made the announcement of the robotaxis, they did highlight that there would be wireless charging with it because a car is not autonomous if it has to still be plugged in. So they went through that process and have made that decision, we think rightfully so, to put wireless charging on it.
So one of the things I'm gonna get technical, David. Sorry. In the world of wireless charging right now, are there any standards, like an IEEE standard, IEC standard, kind of like here's the playbook to get everybody on the same page? Because I think from our perspective, what we really want to avoid and don't want to see is the charging adapter fiasco that's happening right now, and one of the inhibitors to EVs. And I know we're starting to see some standardization with the NACS around here, but internationally, it's such a challenge too. So is there kind of common language, a common standard being developed for that wireless charging infrastructure? So my Audi and somebody else's Tesla and whoever else's doesn't matter. We're all going to be able to park on the same spot and get the same benefits. So my iPhone and my Android are charging off the same wireless charger.
The answer is easily yes. So it's SAE, or Society of Automotive Engineers, J2954. That's the universal automotive standard. Everybody has to meet it. And there's no wiggle room around this situation. So you can't just show up with a different kind of technology that's not operating on the correct frequency and all these other requirements for wireless charging. By the way, the universal frequency for wireless charging is 85 kilohertz. And the reason why that was standardized quite some time ago, over 10 years ago, actually, was because it is an IEEE, FCC, ICNIRP, and we'll say other agencies approved frequency specifically for wireless EV charging. The big thing is that what we don't want to see happening is coupling happening with other devices. So there are other devices even within the vehicle that operate at 120 kilohertz. And so what we don't want to see is that there's an accidental coupling that happens. So 85 kilohertz is the international approved standard. There is no other standard that you can operate with. Then the other point is that there's a lot of other requirements within that. So IEEE, ICNIRP, and all the rest of these kinds of agencies, ISO, they have different parts that they have overview on and supervision on related to from everything from electromagnetic interference to electromagnetic field to what size the system should be to where it's placed at on the vehicle so that you do get a true universal mix so that your Audi could technically charge on, say, a Porsche wireless charging charger or a HEVO wireless charging charger. So all those things have been rooted through the last 12, 15 years of work with major automakers and suppliers and developers like ourselves, helping to build that coalition.
Nice.
So, one of the things that's always happened with anything, when cars were first invented, we needed roads, right? When the EVs came out, we needed places to charge them, right? And one of the great things that Tesla did was they rolled out a supercharger network when they first started selling cars, and they did a lot of benefit for what was just Tesla owners at that time. And until, let's say a year or so ago, I mean, Tesla was always more than 50% of the entire US market. And now in your case, you're trying to get people to change to a wireless charging standard. And it looks like that maybe autonomous vehicles may be the path that makes it, you still have the chicken and the egg syndrome, right? You have to get cars to have the attachments, and the cars then need wireless charging to exist to be able to use that. So does it look like autonomous vehicles are going to be what drives this adoption?
It should. It really should. At the heart of it, the two things that we have seen be the coupling mechanisms that have created this wonderful, if you will, fork in the road is autonomy being certainly one of those things. And the other part of that is other companies trying to outpace Tesla on the technological side. They need to have some kind of advantage that they can offer over a Tesla offering because they still are by far the biggest company in this industry, in this space. You have seen companies like General Motors and others try to catch up, right? So GM has taken number 2 in the pole position for total vehicles sold and delivered in the United States. That's a really interesting development that's happened only over the last couple of years. But whenever you look at the bigger, we'll say, international community of EV developers, manufacturers, and owners, what we're seeing is that certainly this idea of robotaxis is going to prevail, and that is going to need to have autonomy. The reason why, up front, I'm just say autonomous charging. And the reason why up front is that otherwise, these vehicles are returning to a central depot that can be 30 minutes to an hour away from the central business area that they're typically doing pickups and drop-offs. And they're returning all the way over there just to have somebody plug it in, just to have the vehicle drive another 30 minutes to an hour back into the field. Instead, we should be thinking about through this process as vehicles are always topping up. Instead of having to do this full charge constantly, you can have a lower rate of charge just really blending into the city streets at the curbside. And it is just pulling up and charging at loading and pickup locations where there's high, we'll say, traffic for that to do so. So they're just constantly topping up. And that eliminates a lot of the key challenges that they're facing right now. The cost for operating these kinds of operations through plug-in charging is making the model less efficient and therefore economically more expensive. So there is a reason to do that. And you're right, there is a device that does have to go onto the vehicle. Just like there's a device that has to go into the vehicle for plug-in charging. You can't just plug in a car. and then it just automatically starts charging the battery. There's all these other components, inverters, converters, things that have to go into the system to make it have an output of the correct DC voltage for the battery pack. And DC voltages on battery packs are changing right now. So we've seen a surplus of vehicles moving away from a 400 volt DC battery pack, now going to an 800 volt DC battery pack. And so what I can tell you is that our vehicle side package allows for the automaker to automatically have 400 and 800 volt within one vehicle device. They don't have to have a separate technology or architecture for 400 versus having 800. And that's a huge win for them.
Oh, that's nice. That's nice. So, you know, I remember a long time ago, Mike and I were covering this topic on how people, when it was hot outside and they were charging their Teslas, they were pouring water on the charging handle, or they're putting a damp cloth on there. We were talking about the safety of, you know, not electrocuting yourself, you know, by doing that. So wireless charging. And I'm sitting here thinking, what is this going to look like if it's raining outside? Okay,
it's going to look like the asphalt. It's going to look like the driveway. It's going to look like the parking bay. It's going to look exactly like the existing street and concrete and asphalt infrastructure looks like right now. So it's actually odd. It's at odds with the use of automotive drivers, whether they're on the fleet side or residential drivers, to have to place a plug-in charger anywhere where their vehicles are. Why? Because it really takes up a lot of space.
No, I'm thinking of if I'm standing in a puddle while I'm charging the car.
Yeah, you're not going to get electrocuted. I know what you're asking. But my point is that when you're plugging in a high voltage cable into your vehicle, that's an open opportunity for problems to happen. I've had to plug in rain more times than I can count. I never love doing it. It's always, even today still, when it happens, I want to make sure I'm not standing in a puddle of water and that I have at least some kind of soul that's not going to get me electrocuted. So it's been a strange development and relationship with the plug-in charging side. When you're plugging in a system that can power 100 to 250 kilowatts into a battery pack that has 100 kilowatt hours in it, water's not your friend. And so it's something that we're not trained to do as humans. We've been trained to do the opposite. Stay away from power lines, stay away from high voltage systems. And now we're being told, oh no, go ahead and plug that thing in. It's okay if it's raining. So it takes a little bit of courage, I would say, and bravery to want to do that. And you don't have to worry about that with the wireless charging. There's no effects. It's a totally hermetically sealed system. I want to tell you something. So part of the qualifications and certifications that we have to go through is a water test. And so Underwriter Laboratories, or UL, is responsible for the certification for wireless EV charging. And the specific UL certification, if anybody wants to look it up, is UL 2750. We helped to co-develop it. We were part of the originating teams that helped to co-develop that standard, as well as being part of the teams that have been working on the coalition related to the SAE J2954 standards. So to the point, one of the UL certification requirements that you have is that they point what is effectively a fire hose from less than 2 meters away with a flow rate of 200 liters of water per minute at your device, and not one droplet of water is allowed to go inside the cavity of the mechanical housing. You're not allowed. So that's just one of the physical requirements that you must meet in order to be able to have a UL certified technology, which is required to commercialize the tech. And we are both UL and SAE qualified.
That's awesome. That's awesome. So specifically, like, what kind of power transfer do you guys have? So like we talk about level 1, level 2, level 3 DC fast charging. Kind of which area does your wireless option fit in?
So the first technology that we know of in the world to ever be qualified was what we call resonant E8. The E8 it's in its name, 8 kilowatt level certified.
A good old level 2 charger equivalent in there.
Exactly. And so as we've been moving forward with multiple automaker programs, because we have been selected as the reference design for multiple automotive programs, as we've been going forward with that, they clearly want to do more power. There's just always going to be this interest and desire to do so, because they want to make sure that wireless charging can compete at the same power, at the same, we'll say, efficiency, and also at the same price or better pricing than plug-in charging. Okay, so if we look at adoption, the total adoption life cycle, and what it takes to get somebody to an inflection point to make a decision to buy an electric car, well, let's start with the automaker first, because they're the ones that are putting the parts onto the vehicles. And so they study this through something that we would consider is pretty standard, but they want to know something as SWAP C, size, weight, performance, and cost, but in the opposite order in terms of priority and importance: cost, performance, weight, and size. So to answer to your question very directly is that they want to know that the performance is able to compete with plug-in charging. So we have an 11 kilowatt bidirectional technology that we're working to release right now. That's going into an automaker program that has selected for 11 kilowatt bidirectional technology. And that is also thankfully selected us as the reference design for that technology. Now, I will tell you, we are now moving also to 22 to 30 kilowatt systems. And we have tested for 50 to 150 kilowatt systems. But I would also tell you that it's a different kind of wireless charging technology that's necessary to maintain the packaging size and the price requirements in order to do that. If you guys would like, I can break into that a little bit because it's really interesting.
Yeah. No, all of that's fantastic. And we brushed over your opening comments of, like, did you say 93% efficiency on
Correct.
the cycle? That's so, like, my reference when I think wireless charging, like 80%, just as a rule of thumb and where it's at. And that's always been one of the challenges with it. It's just from an efficiency standpoint, you're losing out on traditional there. So getting up in the 90s is crazy.
It's performatively the same.
That's where it's at. Like that's amazing.
Performatively, it's about the same as plug-in charging, because plug-in charging is going to be somewhere between 90 to 97% efficiency. And that's from grid to battery. And if you're getting to the higher efficiency, to your point, you're having to have something that's water cooling those lines in order to have the higher power. So that's just more cost. And the result of that is actually more inefficiency to the power to cost ratio. And so if we're thinking through the lens of power to cost ratio, there's nothing that's better out there in that form of it than our wireless charging technology. So when we look at higher power, one of the key technology breakthroughs that have happened over the last several years is that there's new types of coil designs that have allowed for us to move into higher power without having to sacrifice bigger packaging. So traditionally, it was, if you're going to go to, say, a 25, 50 kilowatt, 100 kilowatt solution, you're probably going to have multiple pads on the vehicle to get over 50 kilowatts. And that's what we have seen traditionally by other developers in the space. And we're not talking about small pads. We're talking about pads on the vehicle that are approximately 1 yard by 1 yard, times 3-4 pads to achieve 75 to 100 kilowatts. That's a lot of copper. That's a lot of wasted space, and it's really heavy. So when we go back to this whole thing about SWAP C, size, weight, performance, cost, it hits none of those where it needs to be at. So about 4 or 5 years ago, we co-developed and began a partnership with Oak Ridge National Labs. And if people don't know who Oak Ridge National Labs are, they're based out of Knoxville, Tennessee. They're a national lab that's been funded by the Department of Energy for all kinds of variations of, we'll say, energy-related deviations. Yeah, exactly.
I've been there. I've been to Oak Ridge. I'm familiar with the National Laboratory.
So you know all about the mushroom cloud developments. All right, got it.
Yeah. My favorite guy, Oppenheimer's, lived there for a long time.
He did. Well, I'm from New Mexico, so everywhere I've ever lived at predominantly has been wherever those guys were hanging out at back in the 50s and
there
the 40s.
You go.
All right, so here's the deal. They got spun out to go work on new ways to accelerate electric vehicles through better forms of electric vehicle charging. And what they landed on was wireless charging. And so the Department of Energy funded programming to develop wireless charging as, we'll say, a public-private partnership. So they did it within the public funding cycle, but they developed private partnerships with companies like HEVO to help along the way to make sure that this is a technology that would be used in these kinds of real commercial kinds of programs. Okay, so fast forward. They created this technology called polyphase. and it's multiple coils in one coil. That's nothing new, by the way. We've seen that in induction now for quite some time. You'll see overlapping coils, etc. This is 6, and they're stacked in a way that they're oscillating on and off in a specific type of algorithm so that they're not overheating. And because of that, it's double-sided. So there's, imagine 3 coils on the top, 3 coils on the bottom, and it's oscillating so that each coil is only coming on for a charge for a split second and turning off. And then the controls are there to ensure that they're doing it in the correct order. So it's kind of like a distribution cap on old engines. It's making sure that you're bringing it up at the right time. Well, here's the news. When we talk about the level of size that we can achieve from a coil size on the vehicle, the best that we've been able to see, if you think of a planar coil or a flat coil, the best that we've ever been able to see and achieved is something in the range of, say, a medium-sized pizza box that could get you up to maximum 11 to 22 kilowatts, okay? After that size turns into an extra large pizza box. And then if you want to go to higher power, you have to have all these extra pizza boxes. Well, with the polyphase coil, we've already tested at 50 kilowatts with a small to medium-sized pizza box. Oh, nice. And have done that very successfully. And so what we have been able to theorize through the modeling, at least, and have actually seen some early testing to, is we can take that to well over 100 kilowatts. We think we could get it up to even 300 kilowatts or even higher within that same size footprint. You can imagine how exciting that is for an automaker, because now they're going, well, what's the cost delta on this? And the answer is about 90% difference. Meaning, if the traditional method would have cost for a 300 kilowatt system $40,000, the cost for this thing, we see it being well under, on the vehicle side, well under $1,000. So it's a 1 to 40x difference. And that, because of that, we're seeing a lot of automakers, especially the German automakers, push hard and fast into polyphase right now. And you should start to hear that technological term show up more and more in conversations about what technology architecture is being used. And we're the key development partner with Oak Ridge on this. So we hold a license to that technology as well. And it's an open license. I'm not trying to act like it's discriminating against anybody to use it. Of course not. But you have to have all the other technology that works with it to ensure that it's working at the most highly efficient operation possible. And so there's where some of our IP lies at.
Very nice, very nice. We had a question in the chat. What will be the distance between the ground and receiver need to be, and will either need to raise or lower to connect?
We don't want anything raising or lowering. That adds cost, complexity, and certainly is going to add disaster to this whole operation. So everything is static. There's no moving parts. There's no reason to add that. You can achieve 10, even up to 12 inches of gap and still maintain a 90% efficiency. There's no problem with that. So it's no longer a size issue. We can do any vehicle under the sun. It doesn't matter if it's class 1 to class 8. All those vehicles have the capability to do wireless charging at the different gap requirements. It's okay. So what we typically see, though, is vehicles are going to be somewhere between 4 to 6 inches for most passenger vehicles. That's the average. Certainly there's vehicles out there like the Cybertruck that has a higher lift on it. They're at the 8-inch level, and they can, I think they can go up to 12 inches even whenever you put them on full suspension. So all the point being is that you don't need to have anything raising and lowering. This technology is capable to have flexibility across a wide range of gaps, all the way from 3 to 8, 10, 12 inches.
Well, what would something like a class 8, you know, I mean, I realize that's tractor trailer, but yeah, what would that clearance be there?
We just saw a Tesla Semi at a roadshow location in Austin, Texas, that we demonstrated an autonomous vehicle, an autonomous commercial van with our wireless charging. So I got to look at it personally. It was the first time I ever saw one. And there's only about 8 to 10 inches of clearance. Okay. So we're going to see that pretty much all throughout as the prevailing height, maximum 12 inches. If you look at locations at port authorities right now, that's probably where you're going to see the highest lift on vehicles, because those are vehicles that are moving and craning around these big containers. And even though they're that size vehicle with those heights, we're still able to hit it. So there is wireless charging being used by those craning vehicles today. And say it as an example, as we understand it, at the LA Port Authority, as an example, who are using autonomous vehicles to move goods around now. So it's becoming more and more autonomous already at those kinds of operational locations. But nonetheless, you would see even these semis, buses, anything in that Class 8 level, anything 12 inches and below, it's predominantly going to be in that range.
That's amazing. So I know focusing a lot on autonomous vehicles, and that's kind of the point of you don't have this people interaction there. But for EV drivers, for people like this who are kind of excited, like I pull into the public spot, I don't have to worry about the charging cable. For charging operators, even in that space where it's like I don't have to worry about vandalism, anymore, and people cutting those cables and what it looks like. So if I'm a driver, have you guys looked at all into like the human machine interface, like the HMI of this? Like how do I plug in? How do I initiate charging? What does this look like? Is it still an app on my phone? Is it accomplished through the vehicle? Do you still have a kiosk associated with these, or is it all just pull up, you have your account, it knows your vehicle, you get going, or is that's still kind of in the works?
Different strokes for different automakers at the moment. We want to see that in game with what you just stated, where the vehicle is treated like its own unique digital wallet. It's so much easier to do that. And it's quite fine because the vehicle equipment is already uniquely identified. And so now that there's a lot of technology development that happened over the last 5 to 10 years on these vehicles that have finally converged together and has made all this more streamlined, capable. And that's not mean to say that they haven't done it yet. Like they still have to do all of it and bring it together. But I think automakers are starting to realize they're really close and all they have to do is just say yes. And so as an example, now automakers predominantly use a encrypted version of Wi-Fi to communicate with vehicle to grid or vehicle to home, like or vehicle to Wi-Fi, right? Yeah. Right. It used to be DSRC and they were so expensive. Those antennas were for sure unimaginably not going to work. We're just going to put it in that way because it was just too expensive. So when they switched over to this encrypted Wi-Fi option, it gave us the capability to do the same with our chargers. So the vehicles are already equipped to be able to already today communicate to our chargers through an encrypted Wi-Fi interface. Okay, so number one, let's start there. The interface is Wi-Fi. It's encrypted Wi-Fi between vehicle to grid charging system. And it is a lock-in. So what's really great is that it doesn't operate as an internet. It operates as like an intranet. And by doing that, that means that people can't just come over there and hack it. Of course, people can always find something to do, but nonetheless, they're going to have to work at it. The second part of that answer is that means that the vehicles are already able to be commonly identified uniquely, so they can operate as a digital wallet. The third part of the HMI is that you've already got really strong infotainment systems that are built into almost every new vehicle platform that can already operate as the key homing in device. If you can imagine the homing device of your vehicle being one beacon and that charger pad on the ground being the other beacon, you can visually see that. We already built that kind of software and we have a mobile app that already does that. But technically, the better outcome is that it's already built into the infotainment system, which, who knows? Maybe we have some automakers that may want to use the kernel data sets and the kernel kind of technology that we've already developed for that infrastructure as well to build it in automatically just to even make it cleaner. But that's how we see it going. So the infotainment system has a visual, lets you know where the charger is. You're pulling up to it. You know when you're aligned. You get out and the vehicle starts charging automatically. All the communications is happening through encrypted Wi-Fi from vehicle to grid, grid to vehicle.
That's amazing, and it's one of our common refrains on here, and one of the reasons so many Chinese vehicles are market leaders right now. I mean, they're effectively a cell phone with wheels.
Yeah, that's right.
They built it with that frame forward, as opposed to traditional automobiles where it's you're coupling that technology on top. But we're really starting to see that in the EV space, where it's just a complete shift of a mindset of like this is a technology platform, and it happens to take you where you want to go. So yeah, that broader integration is definitely something that's really exciting to see out there.
You have to know the Chinese are going to be doing wireless almost immediately, especially now that the Polish team is already dedicated to it. The Cayenne, they're probably going to do other models as well. Of course, that means Volkswagen, that means Mercedes, that means BMW are right behind them. And with Tesla already having made the announcement, it gives those automakers the capability to say, here's an advantage. Now, here's what I got to say. The Chinese automakers have already been playing in wireless charging. BYD has been testing wireless charging for at least a decade. And they did offer it, as I understood, to some level of a degree as an aftermarket retrofit to the BYD buses. But the reality was that also those buses weren't getting purchased and used in the United States the way that they've been being used in, say, China. So there was a little bit of steps that needed to happen between there to unveil that a bit more. Now, XPeng, NIO, certainly BYD, all these kinds of Chinese automakers are leading in a lot of technological grounds within the automotive space. All of a sudden, anybody that's seen any of the BYD vehicles, the Seal, some of these vehicles that are also low cost, so low cost that they've been moratoriumed, cannot come into the United States. There's a reason why, because they're excellent and they also are incredibly affordable. So we're not going to probably see those kinds of vehicles coming into the US anytime soon, especially with the current administration. But that being stated, they're being sold everywhere else like crazy. And so in Latin America, they're being sold like crazy. In Europe, in Africa, in Australia, they're finding markets there. Of course, the United States still represents 20 to 25% of the global GDP, but that doesn't matter. There's so many other markets right now that they're winning in that it's just a matter of time that they do eventually probably find a way to get here. But it will come, I would imagine, with wireless charging as an already built-in native piece of equipment. And that's going to be great because that's just going to put the rest of the automakers on notice that they have to have that to compete. Who's going to want to plug in when they can wirelessly charge? I don't know anybody.
Yeah, we talk about BYD a lot. I mean, Warren Buffett exited BYD back in March. So he, Berkshire Hathaway had been an owner in them for something like 15 years. They'd held a pretty big stake in BYD. But one of the things, like you were talking about with NIO obviously likes the battery swap technology.
Yeah.
I don't think that while they have NIO has 3,000 battery swap locations across China. And I know they're starting to do some in Europe. I really don't see that as being a dominant technology in the cars. I do think in your larger vehicles, like we were talking about the class 3 to class 8, I think battery swap makes a lot of sense when you have a vehicle with 300 to 500 kilowatt hours of batteries. I think it makes a lot more sense there. But, as I've looked at, from you and I's prior conversation, I look at this and I was like, this makes a lot of sense where this should be the dominant technology. You pull into your garage, you have a level 2 wireless charger underneath the car. You don't even, and you have it set that it automatically will stop charging at 80%, at night. And, so it'll just fill that and you have your normal software settings. And if it's sitting on there when it's supposed to, during the hours it's supposed to be charging, it charges. If it's not sitting there, then it's not charging. Some of that seems pretty simple to set. And it seems like, well, and you were talking about the things with, paying for it. We know that in the regular EV chargers, when people say that they have a 20% chance of going to a charger and not actually charging, this failure rate, most of the failures, like 80% of all the failures, have to do with payment processing.
Yeah.
So if you can eliminate that feature, then that people are really going to be able to charge, and it's not that same fear. You fix so many things. You were talking about, fear of charging versus range, or charging anxiety versus range anxiety. But usually the charging anxiety is that charger going to work? Am I going to actually be able to pay for it and get charging? And if you take that whole thing out of the equation. So right now with NACS chargers, it looks like if I were a manufacturer, I'd be switching my cars over to NACS, right? Just because the Tesla network is so reliable. So really, I think we're going to stop seeing so many CCS chargers and things like that. We're certainly not going to be seeing more CHAdeMO chargers, right? But I'm just saying, at some point, you're giving an opportunity for there to be a choice between NACS and something else as well, right? And I think this is a big part of what's going to happen with what you're doing, because Tesla's certainly not going to be able to have a monopoly on charging, which is where it looks like things are headed outside of wireless charging.
We think it should be NACS and wireless. Those should be the dual options on a vehicle. That could be that way for many years. The vehicle side equipment is not that expensive. Say for an 11 kilowatt bidirectional system, we're talking about for $300 or less for the vehicle equipment, our price to automakers. And that's with our margin. So you can do this pretty easily for an automaker. Automakers don't have to put too much work into this. In fact, the only thing that we really need is for them to allow for us to have a couple 4 specific mounting points on the vehicle, which many of them already have those locations that are ready to be used. And then the other part of that is a communication connector, a low voltage connector, and a high voltage connector. So if it has those things, and those are very cheap to produce and to put onto a vehicle, we're talking about a few bucks, then at that point, every vehicle could be wireless enabled. It's up to obviously the customer if they want to have that. But the NACS point is really important, because now that we've been doing this for 15 plus years as a global community trying to adopt electric vehicles to some point, what we know is that you can't have 7 different charging standards. People really don't like that. We're used to having gas stations that we pull up to, and you're going to get the regular unleaded, the premium, or the supreme, and that's it. And that's the way that EV charging needs to start working as well. But it shouldn't be in the gas station model. So I think where we have seen the biggest mistake happen with EV charging is trying to replicate a gas station model. And they even look like gas station stations, right? You see these big boxes with cords that have a pistol that look exactly like if you were putting in a gas pump into your car. Not really the best idea. What really needs to happen is there needs to be a way to always top up. You eliminate this idea that you need the level of battery pack because you're worried about range anxiety, can be tackled by the fact that you don't have to worry about where is there universal charging for me at. And if that's plug-in for NACS, fine. But if it's wireless, great. And if it's both, probably the best option. So what I would say is that, to your many points that you brought up that are really excellent, David, the fact that Tesla established a supercharger network, that was what really made them the supreme leader in this specific industry right now. They established a robust, reliable charging network. Nobody else has been able to do that. It's all been third parties that have not really been in sync with each other. And on top of that, just having all these different corded systems and plugs wasn't a great idea. I would like to see this. This is my hope one day for everybody that does want to drive EV or is considering it and curious to do so, is that you can just pull up to a Walmart, a Target, a Burger King, or to the post office or wherever it is that you're going, and there's just topping up that's constantly happening. The only way to make that work is you got to make charging ubiquitous and universal. You can't do it any other way. And you can't be taking up a bunch of charging, or I should say parking spaces with a bunch of charging equipment. So the great thing about wireless charging is it all goes flush mounted to the ground or below the asphalt. And I know you guys are probably following this, but there's been so much vandalism and so much thievery that's been happening and theft that's been happening with these plug-in chargers. I mean, the UK is in a crisis. If you haven't seen the news, just take a look. They are seeing hundreds of stations be clipped because that's a lot of copper that's in those cables. You know what's really hard to steal wires from? Wireless charging that's in asphalt. You're gonna have to get a jackhammer. You're gonna have to get a saw. You're gonna have to figure out a way to also unbind the hermetic seals and all these. It's it's a completely different game.
I can show you some videos of where people have paved roads in other countries and people are out with pickaxes stealing the asphalt. Okay. So don't think it won't happen.
Oh, it's going to happen.
There's pictures of people stealing the asphalt to go use it at home to like put pavers in their yard or something like that, which is just crazy. But so I want you to think about something. So one of the really big challenges to EV adoption is apartments. So about half of people rent. Okay. And when you look at large apartment complexes, sometimes they'll have a few level 2 chargers. There might even be a DC charger, there for somebody to use. They've never really seen much mass adoption of level 1 charging because people don't have their own spot. Let's think about this. If I owned an apartment complex and I wanted to repave the parking lot, I could put in wireless EV charging. And if everybody was on, your HEVO app to pay for it, anybody that lived there could automatically be having their car charged, and I don't really have to worry about a lot of things. I mean, I think that is probably an area where you could very easily get mass adoption is in the multifamily community, because this has been a problem. People are constantly looking for solutions in that space, and there are things you can do, but a lot of times it requires getting somebody like Mike involved, who's going to come figure out what needs to be done to the grid to put another transformer in so we can handle this apartment complex. I'm also a big fan of level 1 charging, but which, is still trickle top off charging. But have you given any thoughts? Have you had people talking to you about multifamily?
Yes. So it follows a similar kind of trajectory that we would see from centralized depot charging for fleets. They're sort of the same, not exactly, but within the same ballpark. And yes, specifically multi-unit dwellings, those are really excellent opportunities because, look, I'm in New York right now. There's nobody that is going to typically have a personal garage that you can pull into. Most of the time, that's not the case. And most of the time, you're going to be seeing people doing curbside parking, and it's not in a space that is reserved for them. So they're constantly having to play the musical chairs with their vehicle shuffle. However, your point about repaving and putting wireless in, what we don't want to have people think about is, do I have to pay for that? And now is that a new luxury? Instead, it would be something along the lines of this. We know that our cost on our charging equipment falls somewhere between 5 to 10x up to 40x cheaper than plug-in charging systems. So I'll give you an example. Our level 2 systems that are bidirectional, we're pricing those things to be around $1,300 for a level 2 11 kilowatt bidirectional system. And if you do that same pricing against a plug-in charger with bidirectionality, we're easily 5x cheaper, if not better than that against any of those kinds of product offerings. Now, you know how we talked about the pizza box not having to grow in size because we're able to use a new technique, a new technology called polyphase. Because of that, we see even better savings when we get to the higher power levels of, say, 100, 300 kilowatts. We can do 300 kilowatt systems and sell those at somewhere around $6,500. And so compare that to a 300 kilowatt plug-in charging solution. They're going to run for anywhere from $50,000 to $300,000. And that just means that we're able to put in maybe 5 to 10 charging stations for every one plug-in charging station. That's really what it means. And so coming back to your whole point, David, yes, these are great opportunities and locations to do so. Level 2 charging is really, really, really easy to deploy. We don't have to put too much work or effort into doing that. And you technically don't need to reskin the surface. You can just cut out where that location will be at, drop it in like a manhole cover, put some asphalt back around it, cover up the cabling that runs out to the interconnect, and that's it. It's really that simple. So you don't have to do much more than that. And now you have wireless charging at those locations. And so to come to the point, these are the exact scenarios that we're living in right now. That we live in every single day with customers who want it. But what we get to is who's going to own the equipment. That it's really a business model problem more than anything else. It's not a technology problem. It's a business model problem. And the business model says conventionally, somebody has to own the equipment. There's an off taker or somebody that is buying that equipment, right? But I would also tell you, we don't think that's exactly the answer for the future. We think that the answer is that we own, think of it, we see the model being more like T-Mobile. We're putting in and servicing the equipment, and people are becoming subscribers in, and we're maintaining that equipment, and it's low maintenance because it's wireless. So there's not moving parts. There's not cables that are exposed. It's not at the same kind of level of temperate climate problems that you'll see with UV radiation and things like that, right? So we're not going to see that kind of challenge to our maintenance scheduling that you would see with plug-in charging. And therefore, the total cost of ownership is much lower as a result as well. So we see the model needing to change, and we think the best way to see this model is to become a T-Mobile-esque or a telecoms-esque type of company where we're putting in the equipment and offering subscriptions at a level that maintains that equipment and then has surplus.
Yeah, that's the talking to multifamily unit owners. I mean, that's the biggest challenge, and it comes down to, it's like, great, I get it. You know, this would be a feature, but like, where am I going to put this thing? And then
they have to buy
what happens when it does get vandalized? And
right.
It's just one more thing for me to come out and repair. And that's that question: who's going to own this?
Right.
Like, who, and then, you know, who makes money off of it? What does this look like? But it sounds like, I mean, in this system, the way it's setting up, it's, hey, a lot of that's figured out. Like these models, there's subscriptions, you know, as these become more ubiquitous and out in the world in places, like it kind of sorts itself out in some of those models. But yeah, those, aside from just getting infrastructure in place, you know, that's the feedback we hear from people of, well, how do I do this? How do I police it? You know, what does that look like? How do I make sure people are parking in these spaces where they're supposed to be and everything like that, which is still a challenge out there, but those things are starting to resolve themselves, hopefully, in those spaces with alternate models and just kind of a different reality. It doesn't have to work the way it did before. You know,
right.
It can be different.
I know some people in the multifamily space that they will be charge point operators for like a handful of apartment complexes. They have a few level 2 chargers they make money off of in various apartment complexes, and they paid their own money to have this stuff set up, and they seem to make money, you know, on that setup. It's just kind of an awkward, like you said, it's an awkward phase, because then the charge point operator owns those chargers. But you know, and that's probably maybe that's what has to happen here in the wireless charging realm. I don't know. That's the thing is, you know, you want to put a layer of asphalt over the charging pads, right? So, you know, it's you know, where does that come in and, you know, make financial sense to be coming in? And it would make sense, I guess, when you were already planning on resealing the parking lot kind of thing.
It's not really that expensive. So we've already done a lot of modeling and had companies, major construction companies, do their modeling on this kind of integration and installation. It doesn't really change the numbers that much between plug-in and wireless. It's negligible. So it's not, because once you got a team there, they've already got the saws, they're already doing cuts into the pavement anyways, because they're laying in the interconnection. What's another small cut to put a pad into the ground? So it's not that big of a deal for them, and really not that much more time, to be honest. Here's the thing, though, of consideration. It would be almost as if we all had to own our own cell phone towers in the way that it works today. That's not really smart. It's not really inclusive. It certainly doesn't help for mass adoption. The best that we've got right now is a Tesla model for the superchargers, because they own it, but it's built in as a solution. It's a vertically integrated solution. So it would be like T-Mobile making their own phones and owning the towers and having the subscription model. And that's not also inclusive enough to allow for everybody else to jump into that as well. And so there's got to be at least a competitor in the space. We think we can represent that. And we do see a model that will shape out. Maybe initially it's just pure cells, and I can't guarantee it won't be that. But we do want to get to a model where we are able to be part of the infrastructure that's being laid in. We are the the rightful owner of the infrastructure, even if you want to say it that way, on balance sheet or whatever you want to put it in that way. And it's just a finance related matter from that point forward. We know that if we're putting in thousands of chargers and that there are users who are going to subscribe into that on 1 to 2 year kinds of subscription models like you do with your current T-Mobile phone or Verizon or Sprint or whoever you use for your telecoms carrier, it's the same thing. So we, just like towers are shared, so won't wireless charging systems be shared. So just because Sprint built those towers or T-Mobile built those towers, other companies are in the back end able to use those towers to bounce and receive messages for their customers off it too. And there's a clearinghouse on the back end that expertly takes care of that. We need to get to that model at some point. I don't think we're quite there yet, but that's the model that we want to get to. That's the model that we intend to get to help alleviate all these price burdens and the pressure there to do so.
All right, Jeremy, we've really rambled on, but you've been really interesting. And I think you're really onto something here. Obviously, you've been doing this for 14, 15 years, so you must think that too. But,
I hope so.
Yeah. So, on behalf of all our listeners, I want to thank you for coming on our show today. Just hang on. I'm going to go. Thanks everyone for watching, and just hang on just a minute.